How about a geometric series then? Let's try and create a formula for that one. So again, we're adding up all the terms. So a plus AR squared, all the way up to AR n minus 1. I'm going to rewrite it, but this time I'm going to multiply every term by R. And I've deliberately shifted them across so we can see why I've done that. The columns line up nicely now. So I have AR plus AR squared all the way up to AR to the power of n. If I do a subtraction then, all of those terms in the middle disappear and I'm just left with AR to the power of n on the bottom there and the very first term. And we're subtracting. So I've got r minus 1 times sum to n is AR to the power of n minus a. Divide by the r minus 1 and we have ourselves a formula we can use. We tend to use this formula if the ratio is bigger than 1. The only logic behind it I can think of is so you end up with a positive number in the bottom of the fraction. If you've got a number bigger than 1, you get up with a positive. Mind you, if the ratio was negative, it wouldn't matter anyway because you're always going to get a negative number. When it's less than 1, we wrote it backwards. 1 minus r. It's still the same formula. All we've really done is we've multiplied top and bottom by negative 1. That's all. That's good for when the ratio is less than 1. So again, you get a positive number on the bottom of the fraction. You can use either one. It doesn't matter. It's just how we tend to do it, I guess. Well, let's find the sum of the first 10 terms of this particular pattern. The first term is 2, our ratio is 3, and they want 10 terms. So I'll use the r minus 1 formula for this one. Substitute in, I'm old as we know, I would look at that and first of all go 3 minus 1 is 2 and the 2's cancel just to make my calculations easier. You'll probably just plug it all in the calculator. However we do it, we end up with 59,048. Here's one in sum notation. We're going from 3 to 8. The first term is not just 6 in this case. The first term is when n equals 3, so we substitute in n equals 2 and we get 6 times a half squared, which is 3 on 2. Our common ratio, well that would be the half. Remember it's AR to the power of n minus 1. It's still the ratio. And the number of terms, 8 minus 3. 8 minus 3 is 5, but we've got one more, so we've got 6 terms. I will sub in, because the ratio is less than 1, I'm going with the 1 minus r1 for this. And again, you'll probably bung it all into a calculator. I'd be looking at it and going, well 1 minus a half is a half. Oh look, 2's on the bottom of the fraction. Anyway, in fact, look, that is how I did look at that. I've gone 3 on 2 times 63 on 64 times 2 on 1, all sorts of cancelling. We get 189 on 64 as a final answer. This one came from 2 years ago. And it combined this with the stat stuff that we do. So a discrete random variable has a probability distribution as shown. N is a finite positive integer. The expected value. All right, expected value. What was that one again? We needed to write a new table. I'm going to need the XPX row now. So we multiply x with probability of x. So the first one becomes r times r to the power of n, r to the power of n minus 1. The next one, r to the power of n plus 1 as well. That was nice. Oh look, the next one is 2. And in fact, every single one of them turns out to be r to the power of n plus 1. Now, expected value was the sum of that row. So how many do we have? We're starting to the power of 1, we finish with the power of n, so there must have been n of them. And so we've got n lots of r to the power of n plus 1. Hang on, they've said show that it's n times 2r minus 1. Something else is happening here. We know the sum of the probabilities must equal 1. Remember, the sum of all the probabilities must equal 1. So this middle column here, all of those must add up to give 1. So now r to the power of n plus r to the power of n minus 1 and so on is equal to 1. That's where the idea of summing the geometric pattern comes in. I can put it into this formula. So we get r, 1 minus r to the power of n is 1 minus r. Because the first term, although I'm looking at it backwards, the first term is r and the common ratio is also r. We're multiplying by r each time. I end up with that r to the power of n plus 1 is 2r minus 1. That's what I wanted to get to. So now I can go, yes, I have my answer. It's n times 2r minus 1. A little bit tricky, that one. So we'll add 1g to our list of questions.